Good morning, everyone. Our today's topic is 10 laws of cloudonomics. So, yesterday we talked about cloudonomics, that it is something related to the cost, right? So, we discussed whether it will be good for you to opt for a cloud service or you should be having your own private data center. So, we discussed about that. So now we are having different 10 laws related to cloudonomics and how these laws are working when we are talking about or when we are comparing the cost of your private data center with your public data center and how these cloudonomics laws work. So first of all, we are having the first law, that is utility services cost less even though they cost more. Now what does it mean? Whenever we are using any type of utility, the actual cost which we need to spend to produce that particular utility is very high as compared to the cost which we actually pay for it. So just take an example of electricity. So if you want to use 1 unit of electricity, the cost might be, in some regions it might be 4 rupees, at some places it might be 8. but if you think to generate that 1 unit of electricity by putting a turbine on a dam, so you can assume that you can very well imagine what will be the amount of cost for that particular 1 unit of electricity. Okay, so similarly, when we talk about cloud services, so the amount of money which we pay to use a server for 1 hour or for 2 hours is very less as compared to the cost which we need to spend to set up that particular server. So that is why we say utility services cost less even though they cost more in actual. Next is second law, that is on demand trumps forecasting. Now what does it mean? The on demand nature of your cloud helps you to avoid the forecasting, because sometimes, or you can say most of the times, when you try to forecast something in the future, that might be incorrect. So, how on demand can overcome the forecasting thing? You need not to forecast for your resource consumption in the future. What you can do is, whenever you need certain resources, you can acquire those resources on demand. So, you need not to do the forecasting prior to the actual time. That is how it helps you to avoid the forecasting and save your money as well as resources. So that is what the cloudonomics law number 2. Then we are having the cloudonomics law number 3, that is the peak of the sum is never greater than the sum of peaks. Now, what does it mean? That whenever we are talking about any of the company or any of the organization who is having their different demands, so we might be having some certain set of different companies who are having varying demands. Means one company requires some resources at one time, but the other company doesn't require the resource at that time. So what we can do is, we don't need to have the complete capacity at one time. Means we need not to set up a server which should be having a capacity to accommodate all of them, all of the company needs at the same time. So what we can do is, we are having different companies, and what those companies will do, it will balance out the need. So if one company requires 10 GB of sorry 10 GB of storage at one time, the other is requiring only 2 GB of storage. So it will create that kind of a balance. So similar with the computing resources. If some We don't need to deploy the complete computing resources at a single time, because the demands are varying. If the demands are varying, then according to that we can deploy less number of resources, but still we are able to accommodate more number of users in it. That is why under this strategy, the total capacity deployed is the sum of these individual peaks. However, since cloud can reallocate the resources across many enterprises with different peak periods, the cloud needs to deploy less capacity. So that is what we are having in law number 3. Next is law number 4. Aggregate demand is smoother than individual. So aggregating demand for multiple consumers tend to smooth out variation. Specifically, the coefficient of variation of the sum of random variables is always less than or equal to the any individual variable. Now, what does it mean? Whenever we are going to get more higher utilization of the resources, so whenever we combine all those demands, it becomes smoother. It means that we are not having the peak times, we are still continuing at a smoother level. Even if the requirements are increasing, we are having a capacity which is deployed, and users are using those resources, but they will never exceed a particular demand. They will remain in that particular place always. So next we are having law number 5, that is average unit costs are reduced by distributing fixed costs over more units of output. You might have heard about the economics of scale. It is a very important concept when you talk about businesses. So why, if I give you a a real life example, why the cost of a Rolls Royce is higher than a Maruti car? What might be a reason? If you just try to think about it, the very first difference is the brand, of course. The second difference, which is there, that is mass production. When we talk about Rolls-Royce cars, they are not mass produced. They are handmade, they are very special, they are prepared by hands. It takes very long time to develop or to create one car. Whereas on the other end, if we talk about Maruti or any other, not Maruti, you can say any not that high quality cars. So what happens at that time is they are having a economy of scale. So what they do is they keep on generating huge number of cars, and due to that huge number of cars, when they are generating huge cars or huge number of cars, the cost for developing that car gets reduced. So this is the same concept like the unit which is developed for the first time, or the single unit. If you develop a single unit, that will be having the highest cost, and rest all will be having a less cost. So that is how this thing works. Whenever you are setting up your server for the first time, you have to pay the highest amount, but later on, as you scale your businesses, it will become less costly. So that is your law number 5. Next is law number 6, that is superiority in number is the most important factor in result of a combat. Now, what does it mean? Uh, in cloud, if you are having a denial of service attack, in that case, what you need to do is if you are having more number of servers, there is very less probability that distributed DOS attack would work for you. But if you have centralized resources and all the resources are at a single place, and you are having a single place from where whole the network is working, so there are higher chances that your uh, network can face the denial of service attack. Next we have space-time is continuum. Now what does it mean? Whenever we are talking about any type of changes, the companies currently they are having a very scalable, they need to have scalable solutions because they need to work with their competitors, and everyone is trying to chase the other one business. Every business is trying to chase the other business, so they are working very hard to make the biggest profit from their operations. So what they need is a scalable technology. So for that they can use cloud in their services, so that they are able to make some good you can say decision making. They can create strategies for the competitors. So that is what we are having in law number 7. Then we have law number 8. Dispersion is the inverse square of latency. Now, what does it mean? Whenever you want to reduce the latency, you need to increase the number of servers. So that is the simple concept behind it. So if you want to increase the if you want to reduce the latency, so the number of servers which you are going to need are the four times. Like, here is an example: to cut the latency in half, not twice as many nodes, but four times. Now, what does it mean? If there is a latency of 2 seconds and I'm having five servers, so I want to reduce that 1 second latency to 50 seconds, I will have to multiply the 5, that is the number of servers, with 4. It means to reduce the latency by 1 second, I will need to add, or I will need to have 20 servers in my system. So that means just to reduce the latency by half, I will need to have four times of the servers which I am having. Simply to make 2 seconds to cut down into one, we will need 5 into 4, which means 20 servers. So that is what they are also explaining, but they are explaining it in the terms of milliseconds, so don't worry about that. So next one is, don't put all your eggs in one basket. I think it is a very uh, common, you can say, kind of a quote which you might have heard from Warren Buffett, that don't put all your eggs in one basket. That means don't always put all the resources or all your money at a single place. So it is a similar concept, that don't try to have all your servers or all your systems at a single place. So you need to have different redundant data which should be available at different places. So you should not work on a single location. Okay, so what does this particular concept says at this place is, the reliability of a second system with n redundant components, each with the reliability of 1 into 1 minus r into n, so that the reliability of the single data center is 99%. So what they are saying is, even though you increase the number of servers, this availability ratio will never touch 100. It will always remain 99 point something 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 something, but it will never touch 100. Okay, so when you try to move towards the highest availability, to still you need to have very huge number of data centers at that time. Last is, an object at rest tends to stay at rest. This is a law by Newton. So what does it says? That the companies who are who have their servers in their premises, they don't want to shift their resources from that place to another. Wherever those companies were founded, currently their systems are residing at that place. So they don't tend to change it when once they have got their systems set up, they don't want to change it. But it should not be there. They should be changing their resources as per the demand. So these are all the cloudonomics laws. So let us repeat it once again. The first one is, utility service costs less even though they cost more. Second is, on demand trumps forecasting. Simply, you need not to forecast. Your on demand will work for you. You can get your resources on demand instead of forecasting. The peak of the sum is never greater than the sum of peaks, which means that you can combine number of resources. You are having number of different companies who need different resources, so you can get all of them resources at a single place, deploy that capacity, it will never exceed. Then aggregate demand is smoother than the individual, means one, if a single company is having certain kind of you can say requirements, if there are number of companies who are having similar kind of or different type of requirements, so your total overall utilization will increase. Then fifth is, average unit costs are reduced by distributing fixed costs over more unit of outputs. So that is economy of scale. If you are having more number of you can say resources to develop, or more number of items to develop, so your cost per unit will decrease. Similarly, we can talk about it in one another way. So if you need one hard drive, you will need to pay higher cost. If you need 1,000 or 10,000 hard drives, you might compensate with the people who are going to provide you with the hard drives. So similar thing happens with the organizations because they deploy a huge number of systems, so they get it at a lower cost. Superiority in number is the most important factor in the result of a combat. So simply if you are having more number of servers, are having always a better chance to get more availability and reliability on your data centers. Space time is a continuum. Simply if you want to process your work at a faster rate, so your technology should be scalable so that you are able to make good decisions along with the time. Then dispersion is the inverse of square of latency. That means that if you want to reduce the latency to half, you need to multiply your number of servers with 4. So that is 4 times. Don't put all your eggs in one basket. Don't always rely on a single resource. Okay? You need to have high availability of your resources. Then definitely you need to have multiple number of replications of your servers. An object tends to at rest to stay at rest. It means companies who are having their backbone or core network at a single location, they don't tend to change it till the time they don't need, then till the time they don't want to expand. So they keep it at the same place. So these are the 10 laws of cloudonomics. If you have any confusion about that, you can ask your queries. Thank you. Thank you so much.